Introduction to Reflection and Plane Mirrors. In this lesson, we're going to be discussing reflection, terminology, types of mirrors, law of reflection, types of reflection, ray diagrams, locating images in a mirror, lateral inversion, and describing images. Reflection. Reflection is the change in direction of a wavefront at an interface between two different media. That can be air and water, it can be between air and glass, etc. The wavefront reflects off the second medium perpendicular to the surface and returns into the medium from which it originated. So in this case, we're going to be talking about reflection, not the light waves that go through the object, but the light waves that hit the object and come back. Reflection. The clarity of the reflection depends on the mediums. Examples include the reflection of light off an object, as well as sound and water waves. These all demonstrate the same ideas of reflection. Some terminology. So when we say perpendicular, what we mean is that you have one line making a 90-degree angle to another line. So these two lines are perpendicular. If we say they're parallel, that means that they are in the exact same orientation, and they could go on forever in both directions and never touch each other. And when we say medium, we mean a substance that makes possible the transfer of energy from one location to the other. A medium can be air, it can be water, it can be glass. Any substance that the reflection can occur in, or as it says in the definition, where the energy can transfer from one place to another. Terminology. A plane mirror is a flat mirror. It's the kind of mirror that you'd see on your wall. A concave mirror is something that's going to be caved inwards, and we're talking a lot more about this in future lessons. And then a convex mirror is one that's bumped out towards you. So something like those mirrors that you see in convenience stores so that the owner can see around the corners, or that if in the parking lot so you can see when you're coming up a laneway if there's any cars coming in either direction. The law of reflection. The angle of incidence is equal to the angle of reflection. In other words, light gets reflected from a surface at the same angle it hits it. Each arrow represents a ray of light. So if this angle here is 20 degrees, and we're always going to measure it off what's called the normal, which is the line perpendicular to the reflecting surface. If the angle of incidence is 20 degrees, then the angle of reflection is also 20 degrees. Reflection off a mirror. Again, our normal, 90 degrees to the reflecting surface. Angle of incidence is the angle coming in, and the angle of reflection is the angle coming out. The incident ray is the ray coming in, and the reflected ray is the ray coming out. Types of reflection. We can have clear or specular reflection, which is reflection of light off a smooth surface. So in the left picture here, you can see clear reflection. You get a nice flat water, and you get a nice reflection. You can pretty much see that the buildings look the same in the water as they do above the water. And then you can have a diffuse reflection. And that happens when reflected light bounces off an irregular surface. So choppy water. So you can see the example in the right-hand corner, the choppy water diffuse reflection, and you can barely see what the other side is. You can really only see the lights that are reflecting off the water. Now, how do these two work? Well, for a clear reflection, that's the top picture here. You're going to see the arrows are all going to be parallel to each other. So all the reds are parallel to each other, and all the blues are parallel to each other. Now, it's the blues that are going to make our image. So that's what we're going to see. So as long as all the blues are parallel to each other and they're coming in at the correct angles compared to what the reds came in at, then you're going to get a clear reflection. It's going to be easy to see. However, if you have a choppy surface, let's say something that looks like that, where you get this sort of wave front, then when our red hits, our blue is still going to be reflected 90 degrees, but it's 90 degrees compared to the uneven surface. So that's still the same. This is still the same. This is still the same incidence and reflected. The only difference is that the surface is not flat anymore. So now all our blue rays are not parallel to each other, so we don't get a clear reflection. Ray diagrams. A ray diagram is a method used to determine where an image, so that's going to be with our apostrophe, will appear when an object, no apostrophe, is viewed through a mirror or lens. A light ray radiates in millions of directions, but we only are concerned with a few of the light rays that reach our eyes. So in this example here, this is going to be our object up top. This is going to be our, say, plane mirror, and that's going to be the image. So if you're looking at an object in a mirror, you think that it's on the other side of the mirror. Now, we're smart enough, we understand reflection. We know that if we're looking at a mirror, that the object isn't actually located on the other side of the mirror. But if you didn't know that you're actually looking at a mirror, and maybe we're told you're looking at a window, you could say that the object was actually on the other side of that window that you're looking through. Now, in this example here, this is going to be a plane mirror, a plane flat mirror that's going to give us an image on the other side of the mirror. That's our object right there. And this is the image that's created from the plane mirror. Locating an image in a mirror. Since we know light rays travel in a straight line, our brains think that the source is actually behind the mirror. You can see how the incident rays are coming in. That's all these solid lines up top. And when they hit the mirror, they reflect off. Now, when they reflect off, you can see that they're actually spreading out. And they're spreading out because our light source over here is radiating light in every single direction. So it creates these light rays that hit the object and then spread out everywhere. But what our brain does, it takes all these spreading out rays and puts them back together. It extends them to where they would meet, which is on the other side of the mirror. And that's why we perceive the image to be on the other side of the mirror. Now, this is called a virtual image because the image is actually not where the object is. We're not using real light rays to create this image. We're just projecting the light rays to create the image. And we always know when they're not real light rays, as we're going to use dashed or dotted light rays in order to indicate the rays that are behind the mirror. We can use light rays in the law of reflection to determine where our object is located and draw it. We do this using object image lines. So the rules for object image lines include the distance between the object and the mirror equals the distance between the mirror and the object. So again, this is our object up top, and this is our image down below. When we measure the object to the mirror, that's this first line right there, it's going to have the exact same distance as the image mirror line, which is located right here on the bottom. Number two, the object image line is perpendicular to the mirror surface. And again, that's what we have here. We're going to get perpendicular there and there. So all we're going to do is we're going to take a point on the object, we're going to measure its distance to the mirror, say it's 10 centimeters, and I'm going to draw the exact same line going from the mirror on the other side, or make sure they're both perpendicular to the mirror surface. Again, make it 10 centimeters. And we're going to draw our image on the other side. And that's how we're going to be able to locate our image using object image lines. Now, the result of using a plane mirror and object image lines to find that image is we're going to get lateral inversion. Now, lateral inversion is the orientation of an image in a plane mirror is flipped horizontally and in reverse order. So try it for yourself using the object image lines we talked about. So how we can do that? Well, we're going to pick a couple points. Let's pick point 1 here, pick point 2 here, and we'll pick point 3 here. And what you're going to do is you're going to measure them to the plane mirror. So using a ruler, you're going to measure it out, and then you draw that on the other side. So I want you to pause the video and try that out. Okay, so let's try our best to get this done as accurately as possible. So what I'm going to do, again, I have my 3 points, 1, 2, and 3. I'm going to measure 1 to the mirror, and then we're going to measure the same distance on the other side. And that's pretty close. We're going to put a little dot right there. And then we're going to do the exact same thing, perpendicular, perpendicular. We're going to do the exact same thing for 2, which is located right underneath. And then for 3, we know that the distance is like that. So we're going to try to draw the exact same distance there, try to get as accurate as possible, and put our dot right there. And then we're going to fill them in with dashed lines because the image isn't actually there. And then you see our lateral inversion. It's flipped horizontally and on the other side of the mirror. So why do you think the word ambulance is written laterally inverted on an ambulance? When you're driving, what you look at in order to see behind you is what's called the rear view mirror. Now, the rear view mirror is a plane mirror, which means it's going to laterally invert everything that it sees. So when you see an ambulance come up behind you, it doesn't say ambulance written laterally inverted, it says ambulance proper. So you know that it's an ambulance coming up behind you. Now, how do we describe our images? Well, we're going to use an acronym called SALT. So when you describe the properties of an image, you need to examine 4 characteristics and compare them to the object. It's really important, guys, to compare it to the object. Everything is compared to the object. So for instance, S stands for size of the image compared to the object. For instance, it's larger than the object, or it's smaller than the object. 2, A. A is for attitude. Attitude of the image is the way the image is orientated compared to the object. Is it upright or inverted? Again, it's always compared to the object. If our object looks like that, then upright for our image looks like this. However, if our image looks like this, then it's going to be inverted. It's always compared to the object. It doesn't matter if a tree usually looks like this. If the object of the tree is upside down and the image is upside down, then we say that it's upright. 3, L, for location of an image, and that's the distance from the mirror. And then 4, type of image, is it real or virtual? When we talk about virtual, is going to use non-real light rays. A real image, on the other hand, will use real light rays. An image in a plane mirror, remember that's like our rear view mirror in our car, or the mirror that you have on your wall. An image in a plane mirror is always the same size as the object, upright, equal distance behind the mirror, virtual, and laterally inverted. And that concludes our lesson on ray diagrams, reflections, and plane mirrors.